All right, let's dive in. We're going to talk about this powerful, invisible force that's shaping everything around us. But here's the catch. Our brains are just not built to see it coming. This creates a huge gap between how we think the world is and how it actually is. So let's get into it.
Okay, so first things first, we've got to look inside our own heads. Because it turns out we all have this blind spot when it comes to seeing change. And it completely messes with how we see the present and, maybe more importantly, how we even try to imagine the future.
I mean, you know the feeling, right? You're scrolling through your phone, watching the news, and it just feels relentless. It's so easy to get this sense of dread, this feeling that things are spiraling. And it leaves you with this one big question.
So let's take crime as a perfect example. If you look at polls from Gallup, pretty much every year for the past couple of decades, a massive chunk of Americans, we're talking up to 78%, thought crime was getting worse. And it makes sense, right? Psychologists call it a bad news bias. Our brains are just hardwired to look for threats, so we're constantly on alert. And that makes it almost impossible to notice these slow, quiet, positive changes.
But, and this is where it gets crazy, if you look at the actual data from the FBI, the reality is the complete opposite. Since the 1990s, both violent crime and property crime in the U.S. have been slashed by about half. It's just our perception is totally disconnected from what the numbers are telling us.
And this isn't just a random mistake. It points to something really deep about how we think. This gap, it's not a bug, it's a feature. You know, our brains evolved to spot the lion hiding in the grass. That's an immediate, straight-line threat. They just weren't designed to get their heads around slow, compounding progress that happens over decades. It's just not what they do.
Okay, so that brings us to the engine that's driving so much of this hidden progress we can't see: technology. Because tech doesn't move in a straight line. Nope, it moves exponentially, and it's only getting faster.
The futurist Ray Kurzweil gave this a name: the law of accelerating returns. The idea is actually pretty simple, but it's also mind-blowing. Basically, every new technology gives us the tools to build the next technology even faster. So progress doesn't just add up, it multiplies.
The story of AI is the perfect way to see this in action. The first attempts at AI were what you'd call symbolic. Programmers tried to literally write a rule for every single thing. As you can imagine, it hit a wall. It was just too complex. You'd fix one bug and create 3 more. The real breakthrough came with connectionist AI, which is designed to work more like a human brain. It learns from data. Now, this idea was around for decades, but it went nowhere until one thing changed: the hardware. The computers finally got exponentially powerful enough to make it work.
Let's put some numbers on this to make it real. Back in 1965, if you were a student at MIT, you were lucky if you got to share time on this beast, an IBM 7094. In today's money, it costs $30 million. It could run about 250,000 instructions per second. And oh yeah, it took up an entire room.
Now, let's compare that to an iPhone 14 Pro. For what, $1,000? You're holding a device that can perform 17 trillion AI operations per second, and it fits in your pocket. This isn't just a little bit better. It's a completely different reality.
So when you look at the price performance, what you get for your money, that's a 2 trillion-fold improvement. Just try to wrap your head around that number. You can't. Our linear brains literally can't process what that even means. That is the engine of accelerating returns in action.
And here's the thing. This exponential power isn't just stuck in the digital world of bits and software anymore. It's breaking out. It's starting to rewrite the rules of our physical world, the world of atoms.
Just look at energy. For decades, the cost of solar panels has been dropping on this beautiful exponential curve. They call it Swanson's law, and it looks almost exactly like the curve for computer chips. Something that was once ridiculously expensive is now literally the cheapest source of energy in human history.
So here's the big idea, the key takeaway. What technology is doing is turning problems of physical stuff, of scarcity, into information problems. And once something becomes an information problem, you can solve it exponentially. You know, designing a better solar cell, creating a new drug, engineering a crop that yields more food. These are all now data problems that AI can just chew through.
And you see this transformation popping up everywhere. In medicine, AI is designing new medicines in a matter of days. In farming, you've got vertical farms that can grow more food with a fraction of the land and water. And if you look just a little bit down the road in manufacturing, we're talking about programming matter itself, literally building things one atom at a time with nanotechnology.
So what's the next logical step in all this acceleration? Well,
It's probably the most mind-bending of all, turning all this incredible exponential tech inward to upgrade our own biology.
Kurzweil makes this just wild prediction. He thinks that sometime in the 2030s, we're going to hit something he calls longevity escape velocity. Now, what does that mean? It's the tipping point where science is moving so fast that it can add more than a year to your life for every single year that passes. The clock, he says, will actually start to run backwards.
He sees this happening in 3 stages, what he calls bridges. We're on Bridge 1 right now, just using what we already know about diet, exercise, and modern medicine. Bridge 2, which is happening right now, this decade, is the biotech revolution powered by AI. And then Bridge 3, starting in the 2030s, that's nanotechnology. We're talking about tiny little robots in our bloodstream, repairing our cells and fighting off diseases at the molecular level. Wild stuff.
But, and this is a huge but, this future of, radical abundance and super longevity, it's not a done deal. The very same exponential force that could solve our oldest problems also creates our biggest challenges yet.
The Nobel Prize winner Daniel Kahneman framed this perfectly. The benefits of all this exponential tech are huge, but they're diffuse. They're spread out over millions of people as tiny little improvements. But the harms, they are intensely concentrated. Think about it. The truck driver who loses their job to a self-driving truck doesn't feel the small societal benefit. They feel the catastrophic loss of their livelihood.
And this leads to some truly massive risks. People talk about the GNR technologies. That's genetics, nanotechnology, and robotics. What makes them so different and so dangerous is that unlike old tech, they can self-replicate. And that just opens up a Pandora's box of misuse. From AI-powered government surveillance and mass disinformation to, God forbid, engineered pandemics or even runaway nanobots. The promise is incredible, but the peril is just as great.
Which brings us to the final and maybe the most important question of all. The law of accelerating returns isn't really about faster computers, is it? It's this force that's pushing us to overcome the very things that have always defined what it means to be human: our limited minds, our fragile bodies, our short lives. So, as we start to actually move beyond those limits, we have to ask ourselves, what will it even mean to be human anymore?